Hey everyone, today we're gonna predict salary of a new candidate. For HR, it's a tough task to perform different tasks to predict the salary. We create a models in which HR can predict salary of a new hires based on some details like previous college, what kind of roles you want to hire, and city, see previous jobs, graduation marks, and experience. Here we have training sample and testing sample. Our task is to understand the data, and there are some categorical variables we have to convert them to a numerical variables. We have to apply linear regression models to predict the salary and evaluate the results. We get we have 1338 row and 8 columns. Here you can see there previous CTC and CTC are the object variables data types. We know that CTC and previous CTC are the salary of a candidate, so it should be a integer or float types. Also we can check these things. There are we check the how many null value are there. You can see there are no null value available. We see the previous how the data is varying, so we can perform how we can work on this data. Now you can see there are five categorical columns. We know we don't want cities or previous CTC to be a categorical, so we see the unique value of these columns. So here you can see there are double space before the salary of any candidates, so we have to remove this double space. We replace double space to a without space, and convert this data to a float 64 types. Here you can see this, and now you if you run this code, then you will see there are only three categorical variables. In the three categorical variable, college have three variables: tier 1, tier 2, tier 3, three type of college. Tier 1 college have a highest number of candidates, and you can also see there executive candidate are more than manager, and metro and non-metro candidate are almost equals. You can see by a frequency distribution also. Numerical variables, these are the numerical variable we seen earlier. These are the five columns we can see there. Here is the things we can see that previous CTC maximum value is 77,911, and current CTC are the 1,23,416, and we see that mean of the previous CTC is 15,000 almost, but currently it's 73,000, and previous job candidate are four times they can change the jobs in this model. According to the data, they change only four times jobs. Graduation maximum marks is 85, and experience maximum is 64 month. Here you can see the data plots. You can see that previous CTC data is normally distributed, and you can see changes of job change, graduation marks variations, experience variations, and CTC variations. Here you can see that college student of tier 3 college student have a less salary earlier previous salary, but after a CTC they get a very high salary than compared to type 1 and type 2. Also you can see same behavior almost in metro cities, and manager have a higher salary than the executive. Job change, you can see here there whoever change only one times get a higher salary than the two or three times salary variations. Mm, you can see also with the Senate plots, and also you can see with the block box plot. Here you can see there are some outliers. You can see there CTC and previous CTC. These are the outlier available in the our data. But I didn't understand. Multicollinearity. Now we check the multicollinearity of the data. There you can see there are not their data are not multicollineate with each other. You can see with the head map also. Or after that you can see the how more than 1 lakh there are 87 student, and 1 lakh 15,000 there are only 7 students. You can see there are no duplicate value in the all data, and how the things are varying. You can see we can't predict much about these things. Correlations, you can see there are not much correlation with each other data. You can see there are no missing value at here. You can see that kind of things in there. Now we see which parameter are important in our training the models. We rename this college columns names, and after that we perform state models. So here you can see that r square value is 0.608, and importance of this model are almost same, but previous job change and graduation marks are less important based on the p value of the our data. We split the data. We drop the CTC from x variables, and from y variables we these are the x is the our independent variable, and y is dependent on the x. So you can see the x look like this, and now we convert the categorical data into a numerical data using a one hot encoder methods. We drop the first columns also, and we remainder data we are pass through. We give the array names of the data because we drop the first column. So college 1 and college 1 is dropped, and college 2 and college 3 are present here. Now we standardize the data, standardize scales. So you after standardize you can see the value of this data is between 0 or -1 to +1. So here you can see the this data are more uneven. After standardize you can see all the data are in the good conditions then compared to previous ones. Now we can check various influence factor, how the data are related to each other. If there is multicollinearity, we can see there. If this value VF value is greater than 5, then we can see there are some multicollinearity. Or we can, or also if this value is 5 or 10, there is no multicollinearity. In some places it's written 5, or some places it's written 10. Now uh, we perform a training and testing. So now firstly we have to tune our parameter tunings. So we can see how we have to split the data, and what random state give us best results. After seeing this data you can see that 70, 70, 74, 78 at motor number 16, 16 or 15 model accuracy 81.8115, and splitting we have to split data 2.02%. So after that we don't get more than this accuracy, so we split the data based on our results. We transact and y test size is equal to 0.02 and randomness test 15, and we train the models. Or training is on the training our score is 0.60, on testing its score is 0.81. Intercept of our model is intercept is 75,468, and coefficient, these are the coefficient of the our data. And now we checking the model based on the given test data. These are the column in the test data. We know that these are the unknown data. There are no any values are given inside it, so we drop this data, and now we create a data which are look better. We have to predict these columns. This column we have to predict this data are given, so we have to drop this 2, and for x we have to drop CTC data, and y we have to take CTC data, and after that we perform a transforms to convert categorical variables to numerical variables. After that we predict the data. We have to fit the we have to do scaling first, so we do scaling, then we have to predict on the text data. We get these results. We check the adjusted r square value. This also getting almost similar to r square value. We see the mean absolute error is 6,105 nines, and r square value is 0.60. You can now we put the data into a predicted columns, and now we save the model, and here you can see our model is saved. You can see celery.pickles files. Our model is saved, and after that we save the result in Excel files. And these are the conclusions. We see the data which are numericals and which are categoricals. Work on data visualization, handling outliers, convert categorical data into numerical data, see parameter tunings, and linear regression models to fit the models, and testing. We prepare the testing data, and after that we calculate the r square value, mean absolute error, and square errors. Thank you everyone. Hope you like this.